Hello students, welcome. Previously, lesson 8 form 2 topic 2 we were introducing alkaline earth metal. So today lesson 9 we are going to proceed to the physical properties of alkaline earth metal. Here we have a table of the physical properties of alkaline earth metal. Okay, we want to proceed to the first physical properties of alkaline earth metal, and that is appearance and ease of cutting. So we're saying when an alkaline earth metal is polished, it acquires metallic luster. Alkaline earth metals lose their metallic luster when exposed to the air. Reason, this is due to oxidation, or this is because of oxidation, or they react with the atmospheric air. That's why they are going to lose their metallic luster when they are exposed to the atmosphere or to the air. So next we are told when alkaline earth metal are used or are supposed to be used in experiments, before using them in experiment, they are supposed to be polished. So reason, we are saying here, the purpose of polishing the surface of alkaline earth metals before using them in experiments is to remove the thin oxide layer that usually forms on their surface. Okay, next we are told alkaline earth metals are hard to cut with a knife. They are not soft and easy to cut with a knife like alkali metals. Instead, they are hard to cut with a knife. Hence, magnesium is said to be ductile and malleable, while calcium is said to be brittle. So what is a ductile material? A ductile material is a material which can be drawn into a wire. Okay, what about malleable material? Malleable material is a one which can be hammered into sheets. So what about brittle substance? Is a one which is hard and likely to break when hammered. So we're done with the first. Next, we are going to go to the second physical properties of alkaline earth metal, and that's the melting and the boiling points. So if you know the melting and the boiling points of alkali metals, even you know the melting and the boiling points of alkaline earth metal. Remember, alkali metals and alkaline earth metal, as we have said earlier on, they have some similar properties because they are both metals. Okay, we are saying the melting and the boiling points of alkaline earth metal decreases down the group. You give the same reason that you give when you are dealing with the trend on the melting and the boiling point of alkali metals. And the reason is due to the decrease in the strength of the force of attraction holding the atoms together as the atomic size or as the atomic radius increases down the group. Example, we are told magnesium has a higher melting point than calcium. Reason, this is because atoms of magnesium are small, hence are held together by strong force of attraction between these atoms. Then calcium, which are large or which have large size, hence held by a weak force of attraction between these atoms. Next, number 3, we are going to go to ionization energy. Remember, alkali metals are having only one electron in their outermost energy level, so they were having only the first ionization energy. But alkaline earth metal have 2 electrons in their outermost energy level, so they are expected to have 2 ionization energy. That's the first ionization energy and the second ionization energy. So what have we said about defining first ionization energy? First ionization energy is the minimum amount of energy required to remove an electron from the outermost energy level of an atom in the gaseous state. So what about second ionization energy? It's the minimum amount of energy required to remove a second electron or an electron from the outermost energy level of an ion in the gaseous state. Initially, it was from the outermost energy level of an atom, but now it is from the outermost energy level of an ion in the gaseous form. Okay, next, let us see the trend in the first ionization energy of alkali metals. So it will be the same as the trend of ionization energy in alkali metals. So we are saying the first ionization energy of alkali earth metal decreases down the group. Reason? This is due to the decrease in the strength of the force of attraction holding the atoms together as the atomic size or as the atomic radius increases down the group. Because once the atomic radius or the atomic size increases, that means the ionization energy decreases. Okay, example. Here we are having the first ionization energy of magnesium is higher than the first ionization energy of calcium. Reason? This is because magnesium has a small size, hence has a stronger force holding its atoms together than calcium, which has large size, hence has a weaker force of attraction holding its atoms together. Okay, next, let's now compare the first and the second ionization energy of alkaline earth metal. And we are saying the second ionization energy of alkaline earth metal is always higher than the first ionization energy. So we're saying the second ionization energy is always higher than the first ionization energy of alkaline earth metal. Reason? This is because once an electron has been lost from an atom, the overall positive charge holds the remaining electrons more firmly. Then that means removing a second electron from an ion requires more energy than the first electron. Okay, how are we going to have the first and the second ionization energy of maybe alkaline earth metal? For instance, that side of magnesium, we are going to have, first of all, the first ionization energy. The first ionization energy of magnesium, we are going to write, first of all, magnesium atom, which is in the gaseous form, then loses one electron, and this will be the first ionization energy, and it is 706 kilojoules per mole. That's the energy. Okay, if we want second ionization energy, so second ionization energy for that magnesium, second ionization, second IE will be magnesium ion, which is in the gaseous form, then losing a second electron. Now we are going to have something like that, and the ionization energy will be 1450 kilojoules per mole. Kilojoules per mole. So what are we saying? We're saying the second ionization energy is always higher than the first ionization energy, because once an electron has been lost from an atom, the remaining electrons hold the overall positive charge holds the remaining electrons more firmly. Then that means removing a second electron from an ion requires more energy than the first electron. Next, we are going to go to the last side, that is electrical conductivity. So the electrical conductivity of alkali metals, we are going to alkaline earth metal, we are going to say alkaline earth metals are good conductors of heat and electricity. Reason? This is due to the presence of delocalized electron in their structure, just like alkali metals. Okay, what about if we are told to try to compare the electrical conductivity of alkaline earth metals? We are saying since all members of alkaline earth metal have 2 electrons in their outermost energy levels, hence they have similar conductivity. Like for example, calcium and magnesium will be having the same electrical conductivity. But if you are told to compare the electrical conductivity of alkali metal and alkaline earth metal, then we are going to say alkaline earth metal has a higher electrical conductivity than alkali metals, because they have more delocalized electron than alkali metals. Remember, alkaline earth metal have 2 delocalized electrons, while alkali metals have 1 delocalized electrons in their structure. That is the end of our video.